really nice little cheat paper that I'm going to give you. And Lyle, I brought another copy for you. But I didn't know if you would have it handy.
What does it look like?
Attack strategy.
Yeah, I have it somewhere.
Yeah, I know you have it somewhere.
No, what's in the folder?
Here's a whole bunch of practice problems, and then for each one there's also some hints about how to go about solving them. And then here's a packet of stuff that goes with your open response part. This is just copied out of a green book. So there's periodic table, reduction potential table, and then these formulas are all given to you for the second part of the exam. You don't get them for the multiple choice, which I think is a darn shame. But you do get them for the open response, so you don't have to memorize a whole bunch of equations. Okay? They figure if you've got a calculator, you might as well have the formulas, because otherwise you're going to be tempted to store the equations in your calculator. So, what else is going to give you? The attack strategies page. And there are some sample problems we're going to work through. And that's in the format that the questions appear now. They used to be in a different format. I think 2008 they changed the setup for problem number 4, and it's just like that now. Okay. All right. So you have your attack strategies. Okay. There's a new packet of questions. We're not going to work through that today. There's that. I don't know if you had that. You have your attack strategies, and there's the problems we're going to work through. And here's a copy of all of that for you. Okay, so looking, I need my papers. I'll give them to you. Okay, no, no. Okay, so looking at the attack strategy, this gives you a systematic kind of way of simplifying net ionic equations so that you don't always have to, it reduces the amount of time you have to spend on the problem, number one, and it also makes it a little bit easier for you to see the pattern that is developed with them. Now, this doesn't give you all of the hints, but this kind of gives you the most common things that tend to occur and ways to deal with it. So number one, know your solubility rules. And as my students have learned this past week, solubility equilibrium problems don't always obey solubility rules. But for this equation, or for this problem, these solubility rules are going to determine whether or not you say a precipitate is formed. So if you see the word nitrate, it's going to be soluble, unless it says solid or crystals or gives you some indication that you have a solid material. If it just says sodium nitrate or iron 3 nitrate or whatever, presume it's a soluble substance. If it's a group 1 metal or ammonium, it's going to be soluble unless otherwise stated. So you don't have to stop and ask. If you see sodium, unless it makes it clear that it's a solid, then it's going to be dissolved in solution. Halides, those are your group 17. There are your notable exceptions. Mercury 1, lead 2, and silver are all going to be insoluble for the halides, and those are the only 3 exceptions that you need to worry about. And they do show up with frightening regularity, the exceptions they are, especially silver chloride and so forth. You must know your strong acids. You shouldn't have to stop and think about which acids are strong. There are no 6 known strong acids, just have them memorized. And you know the formulas for those then?
Everything except for perchloric.
Perchloric is HClO4. And then it says write them as dissociated. So if you see hydrochloric, it's going to be dissociated into hydrogen ions and chloride ions. Sulfuric, when it is concentrated, is not broken down. It's a little bit better than 97% undissociated. So if you see concentrated sulfuric acid, you leave it as H2SO4. And then carbonic acid always dissociates into carbon dioxide and water. Your strong bases are your group 1 metal hydroxides or oxides. And then group 2s except beryllium and magnesium. So beryllium hydroxide, magnesium hydroxide do not dissociate because they're weak bases even though they behave like strong bases. I'm sorry, even though they look like strong bases. Okay? Then it gives you some further tips down there. Look for things that have boron with halides. Boron with halides violate the octet rule and form readily with ammonia, NH3, because ammonia has a lone pair of electrons. So it forms a coordinate covalent bond with boron tri-whatever, boron trifluoride, trichloride, triiodide, and so forth. It almost always shows up as a synthesis reaction or a combination reaction or an addition reaction, whatever you learned it as. It's rather common and it's often missed. And since it shows up so often, I'm still surprised it's missed so often. And basically, you have a Lewis acid Lewis base pairing where one is going to donate the electron. Alright, on the second page, this is where you get into some practical information about how to simplify things before you actually write. They don't care when you write on your answer pages for problem number 4. They don't care what you write as long as the right answer goes into the box. And I don't even know if they have a box anymore. It really does look like this paper right here as far as how it's presented. And so the space that you have to write your final answer is fairly limited. So if you need to work out the problem, if you need to write it in full molecular form and then break it down, I would make sure you do that on a piece of scratch paper or something else. You don't want your final answer confused with a working answer, because you'll lose points on that. So what they recommend is anytime you see the word nitrate, cross it out. Just put a single horizontal line through it. That draws your attention away from it so that you're not tempted to write NO3 anywhere. Circle words that imply solids or gases because they are not going to be dissociated. And these are for your reactants. So again, it draws your attention to that so that you make sure that you don't break those apart. Cross out group 1A metals unless it's associated with a solid or a gas. Underline your halides. Underline your halides. So those are your group 17s. Paying attention to whether or not they're combined with insoluble metals. So silver, mercury 1, or lead 2. If they're with a soluble metal, then you can cross it off. And it gives you an example of hydrochloric. Hydrochloric, strong acid, so the halide, chlorine, is crossed off. We know that it's going to be a spectator ion, so we can ignore it. If you see anything, this is one that students miss a lot. If you see anything that says burned in air, that's combustion. Okay, that makes it an easy equation to solve. You see a combustion equation every once in a while. I wouldn't count on one because they aren't easy to spot. If you see the word concentrated, pay attention to what it's attached to. If it's attached to sulfuric acid, do not dissociate. If it's associated with nitric acid, then you know what one of the products is going to be. If you see the word excess associated with that, it influences the products as well. But I was reviewing some of Renee's notes at the beginning of the year on this material, and she said, for this problem, they'll take any reasonable answer as a product. So you can't react a hydrocarbon with oxygen and come out with a salt of some kind. That's an unreasonable product. But if you come up with a possibility, you're combining, you get carbon monoxide as a product rather than carbon dioxide. As long as it's a reasonable product, they'll accept the answer. So there's really no reason why people don't do well on this problem. Okay. You get 1 point for writing the reactants in their proper form. You get 2 points for writing the products in their proper form. You get 1 point for balancing, and then you get 1 point for the question. And also, on the balancing, if you write a reasonable equation, even if you think it may not be right, write a reasonable equation and balance it. Even if it's the wrong equation, you get the point for balancing. So always try to balance it. Okay? Down near the bottom, we see we have metal oxides reacting with water. You're going to give yourself bases. So if you take lithium oxide or something, Li2O, and you react it with water, you're going to get lithium hydroxide. That's a strong base because it dissociates. Non-metal oxides, you're going to get acids out of that. So make sure you recognize that if you take metal oxides, you're going to get bases when they put in water. If you take a non-metal oxide, you're going to get an acid when you put it in water. Metal carbonates, when they're heated, are going to give you a metal oxide and carbon dioxide. These are little tricks to help you maximize your points.